Welcome back, grade 9 students. Today we're going to go over a brief review of everything we've learned about static electricity so far. So a lot of this is going to be a review. For some people, it might be a little bit of new information, but it's been a good number of weeks since we last met, so a review is warranted. All the information in this review is from Chapter 10, Section 10.1, pages 394 to 401. If there's any terms or concepts that you need to go over again, head to the textbook and reread these sections. Firstly, we talked about electric charges. So electric charges are charged particles that exert a force on one another. And we can talk about negative charges and positive charges. Now that should sound real familiar because when we talked about the structure of the atom in our previous units, we talked about positive and negative charges. Protons are positively charged in the nucleus of the atom, and electrons are negatively charged orbiting around that nucleus. And this is where the charged in charged objects comes from. Now let's take a look at some objects. I got a nice little white box here, and you can see in the box there are 4 positive charges and 4 negative charges. So those charges all even out. We can say that this object is neutral. It has no overall charge. It's not negative. It's not positive. But this box, it's got 4 positive charges and 2 negative charges. There's 2 more positive charges than negative charges, so it is overall positively charged. Now, this one has a whole bunch more electrons than protons, so we would say that this object is negatively charged. Now, when an electric charge builds up on the surface of an object, this is called a static charge or static electricity. Now, when we use the word static in science, we're talking about something that stays put in one place. So a static charge is an electric charge that is located in a particular region on an object. Really important to note. Remember when we talked about covalent and ionic bonding? It's always the electrons that are moving around from atom to atom or being shared between atoms. The same thing with static electricity. The protons are stuck in the middle in their nucleus. They're not going anywhere. The electrons are floating around. They're very light, so they can fly off and join other atoms, move between objects with ease. So electrons move around. Protons never move around. They stay put. So we can demonstrate static electricity by rubbing 2 objects together. So rubbing 2 objects together creates friction. Friction is the force resisting the relative motion of 2 objects. This is enough force to grab electrons from one object and transfer it to the next. So we've got a yellow box and a white box. They've been rubbed together, and electrons have now moved from the white box to the yellow box through the force of friction. Remember, only electrons move, protons always stay put. Now, the white box lost a bunch of electrons. So now it's got way more protons than electrons, so we can say it is positively charged. The yellow object gained a bunch of electrons, a bunch of negative charges, so now it is negatively charged. Here's another example using real-world materials. This is straight from your textbook. It's a piece of amber being rubbed against a piece of cloth. So they start out being neutrally charged, both of them in the beginning, A. Then B, they get rubbed together, force of friction going on. And then at the end, the amber gains electrons and becomes negatively charged, and the cloth loses electrons and becomes positively charged. So this is kind of important. So if you rub two objects together, how do we know which one is going to get the electrons and which one is going to lose electrons? So the ability of a substance to hold on to its own electrons is called electron affinity. So when we're talking about affinity in everyday language, that's just how much a person or an object is attracted to or likes another person or object. So if I have good affinity with Robert, that means me and Robert are great buddies. We love hanging out. We've got a strong bond of friendship. Similarly, when we're talking about electron affinity, it's the affinity that a material has to electrons. So if amber has a strong affinity, electron affinity, that means it really loves electrons and it really wants to hold on to them. And if cloth has a low electron affinity, it means it has a weak connection to electrons. It doesn't hold on to them very strongly. If we go back to our original example here, our white box lost electrons. So we could say that it has a low electron affinity, or at least a lower electron affinity than the yellow box. Similarly, the yellow box gained electrons. It stole electrons away from the other objects. So it is a high electron affinity or a higher electron affinity than the white box. But when we're talking about everyday real life objects, how do we know which one is going to get the electrons and become negatively charged and which one is going to donate the electrons and become positively charged? Well, we look up the objects on something called a triboelectric series. This is table 10.1 from your textbook. So when you rub any of these two objects together, the one with the lower electron affinity or higher on the table here will lose electrons and become positively charged. The one with higher electron affinity will gain electrons, becoming negatively charged. That's lower on the table here. Let's go back to our amber cloth example. That's cotton right here, about halfway down the table, and amber closer to the bottom. Cotton is higher on the table. It has a lower electron affinity, so it is not going to hold on to electrons very strongly. Amber is lower on the table. It is a higher electron affinity. It will grab electrons and steal them away from cotton. So amber, because it's lower on the table, because it has a higher electron affinity, that's the one that's going to get electrons. That's the material that's going to become negatively charged. So this was the first assignment that I gave you in the Created Children's Book or Cornell Notes assignment. If you don't know the details of this assignment, there's another YouTube tutorial video that you need to go watch and make sure you've got all the correct information there. For the children's book, your first page should be from pages 394 to 398, and you're illustrating the example of the amber and cloth being rubbed together or any other two objects being rubbed together. In class, we used a balloon and hair. You can use whatever objects you like, but make sure when you're giving your description of what's going on, you're using the terms electric charges, static charge / static electricity, friction, and electron affinity. Cornell notes, page 394, 398, and those exact same terms. If you go to that YouTube tutorial video, there's actually examples of completed projects or completed pages for exactly this assignment. Go check those out again if you have to. Just to cap this off, we've got just a couple definitions that we've already covered. So conductivity is the ability of a material to allow electrons to move freely within the material. Good conductors of electricity allow electrons to change position or flow through the material. And insulators do not allow the flow of electrons over those materials. Some materials, like this green box here, allow those electrons to move around. So we call this green box a good conductor. Some materials are resistant to the flow of electrons. So this orange box, the electrons are staying in place. So we call this box a good insulator. Now here's a real life example. Copper wiring in electronics. The copper wiring in the center of the wire is a really good conductor of electricity. It allows the electrons to flow right through it. Perfect. That's exactly what you want when you have an electronics. When you're working with electronics, on the outside of the wire, there's a rubber coating that doesn't allow any electricity to flow through it. That's great because you don't want to pick up a wire and have electricity flowing through your hand whenever you touch one of these wires. So the rubber on the outside of the wire is an excellent insulator. If you want more, go check out these YouTube videos. They're great. They cover some of the same material and more. Check them out. So today, what I'm asking you to do for the lesson is I want you to review this material that we just covered. Make sure you double back and go over any terms or concepts that you need to touch up on. Again, it's section 10.1, page 394 to 401. We have already worked on this first page of our notes. Some people have already handed it in. Most people will already have this mostly done. If you haven't completed it, please finish it up now and take a picture or scan it and then submit it using the Google form on the Google Classroom. And again, if you need a refresher on exactly what I'm asking here, go check out the previous YouTube tutorial video on how to do the children's book / Cornell notes assignment. Lastly, once you're confident with all this material, quiz yourself using the Google form. And we're going to try out a Kahoot as a class at 2 p.m. today. So April 9th, Thursday at 2 p.m. on YouTube Live. Now, I've been informed that your Google accounts won't allow you to use Google Meet. So we have to scrap that part of our plan for office hours. We're going to try to do it through YouTube Live. So if you have any questions, concerns, or comments, you can join the YouTube Live at 2 p.m. and we'll try to get a Kahoot going through there as well. If that doesn't pan out, I'm going to post the Kahoot code on the Google Classroom just to make sure that we get it done. Okay, perfect. So check up on this work, review the material, make sure you're done that first page of your children's book / notes and submit it to me by the Google Classroom. And lastly, once you're confident in this material, take the Google form quiz and join us for a Kahoot at 2 p.m. Thank you and enjoy.